Hi, welcome to the Calculus 1 lecture series. This is lecture number 3, calculate limits using the limits law. And this is the second part of this lectures here. And on the first part, we introduced the several limits law and how do you use that. And then we also start take a look at how about how to deal with the rational function. That means function with the denominator. So if the denominator is equal to 0, then how do we deal with that? Okay, so let's go back to our lecture notes here. Okay, so from the previous video, we stopped at here, how to take care of the division by 0 for the rational functions, right? So we say the first things you can do is you can do the sum cancellation by factoring. So to see if you be able to factoring out some similar term, the term give you the trouble. And then the next ones here, we say sometimes you cannot factoring. So you might need to think some other methods here. So the other methods here, we say sometimes maybe you can just do some manipulation for your fractions, or you can try to rationalize your expressions here. So let's take a look at what we did here, right? Okay, so now in here, we want to see here. So let me give a little bit of more space here. Okay, so for these ones here, okay, so for these ones here, we said x approach to 3. And so what is this limit? As always, we say, hey, you always substitute first. So we say this will be when x equal to 3. So it will be square root of the 3 minus square root of the 3. And the 3 minus the 3. Oh boy, what I have here? Oh, I have a 0 over 0 here, right? Okay, so if I have a 0 over 0, so how do I do that? So in here, the typical way, if you know, there's nothing I can factors, right? And so I can do is, that's what we call it is the rationalize here. What I mean is rationalize here. So this is limit. So this is x minus square root of the x minus square root of the 3 and the x minus 3 is here. So what can I do here? I can do is I can times the conjugate. What is the conjugate? The conjugate is the 1. So this is x square roots plus the square root of the 3. So I cannot just times anything. So I need to times the same thing for the denominators here, right? So take a look at how these things here basically is what? It's 1s, right? You did not really change anything. It's just times 1. And then now I'm using one very important formula in the, you know, in the factoring. We say a minus b times a plus b. What is this ones here? So this is what is a square minus b squares here, right? Okay, now let's take a look at what happens here. Okay, so this is the limit x approach to 3. So the bottom is not changed, right? So bottom is x minus 3. I times this is x square roots plus 3 square roots of 3. Okay, so now here this is a minus b times a plus b. So what is your a here compared to your formula? Your a is the square root of x. What is your b here? Is the square root of the 3's, right? So you use a minus b times a plus b equal to a square minus b square. So what happened to the top here? Is a square. So square root of x you square. What is here? X. The square root of the 3 you square. What is that? X minus 3. Oh, wow, I see something. So this is x minus 3, x minus 3. I can cancel, right? Okay, so now what is I have left here? So I have a limit x minus approach to 3, and then this is the square root of the 3 square root of x plus square root of the 3. Now you substitute to the, so it's square root of the 3 plus the square root of the 3. So what is here? 2 to the square root of the 3, right? So, you know, if you like, you can kind of the simplify, rationalize a little bit more. So this is 6 square root of the 3. Or you can just leave this form. That would be good. All right. Okay, so now let's take a look. So let's take a look here. The next ones here. Let me give a little bigger space here. Okay. All right. So now for these ones here, let's take a look. Remember, we always want to what? Plug in first, right? So x equal to 0. Okay, see what happens here. So 0. So this is 1 plus 4 plus 0 is what? It's 4 minus what? 1/4. So what I have here? 0 over 0. All right, so what can I do? Nothing I can factor, nothing I can rationalize. Maybe I just do some manipulation of my fractions and to see I can simplify these fractions or not, okay? All right, so now let's see here. So the x here, so top, what can I do? Common denominator. So what is the common denominator? It's x plus 4 times what? X, right? Then minus x plus 4 times x, right? Common denominator. So what is, oh, not an x, it's 4. Now pay attention, 4. All right, so this is a 4. Okay, so x plus 4 times 4, x plus 4, 4. Okay, so what is here? This is what? This is 4. What is here? This used to be 1/4. So what is here? This is 4 plus x or x plus 4. Doesn't matter. Okay, so now just need to be careful about my algebra. So this is x here. So this is x plus 4 to the 4. Then this is 4 minus 4. Be careful. This minus sign apply to what? To both, right? So be very careful for that. So it's 4 minus 4 minus x. Oh, not bad, pretty good. So this is limit x approach to 0, then x here. So this is negative x, x plus 4 to the 4. All right, so now I flip it, right? So this one will be equal to the limit x approach to 0. So this is x plus 4 times 4, negative x, 1 over x. What I see here, x cancel. Okay, so now that's good. So I will have, this is the limit x approach to 0. So don't forget I have still this negative sign. So it's x plus 4 to the 4. So now you plug in the x equal to 0 is what? 4 times 4 is 16, right? So it's negative 1 over 16. This is what we mean manipulate your fraction, because it's kind of like the complicated fractions, right? So you want to simplify it. Okay, so now let's take a look at this one. See here. Okay, so this is limit x approach to 0 to x squared x minus 3. All right, so let's take a look at the first one. X equal to 0, so it's 0. Okay, so 0 minus negative 3 is what? This is negative 3, right? Okay, then plus here, the x approach to 0. What is here? This is 0. And then what is 0 approach to here? Hey, this one is 3 here, right? Okay, so this one, do we need to do anything about it? No, not really, because the x approach to 0 is inside the domain of both these functions here, correct? So I know, so I say, okay, this one here is 0 to the negative 3 plus 0 to the positive 3. So I know for fractions here, if, the denominator is not equal to 0, numerator equal to 0, what is this one here? It's 0, right? So both of them is 0, so it's 0 plus 0. So the answer for this limit is 0 here. So don't let it trick you, right? All right. So now let's take a look at this one here. Okay, so this one's here. Okay, let's okay, so let's let me see here. Can we erase this? Okay, good. All right. Okay, so this one's here. We want to okay, find the limit x approach to 2. Oh, this is a piecewise function. And I want to find the approach to 2 and it break at 2, right? So what do we need to do? I know I need to do the left-hand side and the right-hand side, right? So let's take a look. So limit x approach to 2 from the right-hand side. Okay, from the right-hand side is greater than 0. So which one is greater than 0? The bottom ones, right? So, okay, so I need to, so this one's here. This one will be x squared minus x minus 2. This is x squared minus 4. Like I say, always substitute first, right? So x equal to 2. This is 4 minus 4. This is 4 minus 2 minus 2. What I have here? 0 over 0. So I know I'm in trouble for 0 over 0. So I need to go through what can I do. I say, okay, let's see we'll be able to factor. I said, okay, this is, yeah, I know this is x minus 2. This is x plus 2 on the bottom. Then here, this will be x minus 2, x what? Plus 1 here. Correct? Okay. Okay, so now I'll be able to, so this is, oh, good job, x minus 1 cancel out. So this will be equal to limit x approach to 2 from the right-hand side, x plus 1, x plus 2. So it's 2 plus 1 is 3, 2 plus 2 is 4, right? So it's 3/4. Okay, so now let's take a look at the limit from the left-hand side, right? So from the left-hand side, that means less than. So which one I'm using here? I'm using the top ones here, right? So this is x squared minus 4. This is x minus 2. Okay, substitute. So 4 minus 4, 2 minus 2, 0 over 0. Okay, so I know this one here is indeterminate. So I say x2 to the negative from the non-negative from left-hand side. So this is x minus 2, and this is x plus 2, right? So this is x minus 2. Oh boy, that's good. I see x minus 2, x minus 2 cancel out. So what I have here, I have this is equal to the limit x approach to 2 from the left-hand side, x plus 2. So what is here is 4, right? So then we notice here, 3/4 is not equal to 4. Oh boy, if left-hand side limit not equal to the right-hand side limit, what is our conclusion? So we will say limit x approach to 2, the f of x is exist or not exist? It's not exist, right? So it's do not exist because of the right-hand side limit and not equal to the left-hand side limit here. Okay. Okay, so the next thing is here, we're going to talk about a comparison and the squeeze series here. Okay, so the comparison series. So first, let's take a look at the comparisons here. So what is the comparison series here? Okay, so for the comparison here. So let me do a picture. Probably that would be easier to then to write into the. Okay, so if I have functions here, if I have this is my f of x functions, and let's see here, this is my green one, this is my h of functions, and here, then I have another functions here, the red one, this is the gx function, and now I have a point A here, right? So comparison series tell you here. So that means what? So all your functions, f of x is less than gx, less than h of x here, okay? And then we know, so if this is all this, okay, so then we know that when the x getting closer to a here, then we say the limit x approach to a, the f of x is going to be less than limit x approach to a, the gx, and going to be less than limit x approach to a, the h of x, right? Because here will be, so this point here will be your limit. So it's obvious from the graph here. Okay, so now let's take a look at what is the squeeze series here, right? Okay, so for the squeeze, so, okay, so this is the comparisons, right? Okay, so for the squeeze here, let me do the same graph here. Okay, so now do the same way. I have a f of x go like this. This is my f of x here. And then I have h of x. So this is h of x here. Okay, so this is h of x. Okay, now my gx is here, right? So the gx is somewhere in, okay, so this is gx here, okay? So what is the squeeze theory tell you? The squeeze theory tell you here. So we still have f of x less than gx less than h of x here. For all of x, okay, near the a, and the limit, so the here we said the limit x approach to a, f of x, and limit x approach to a, h of x, both exist, okay? And we know the limit x approach to a, the f of x equal to the limit x approach to a, the h of x, so they are equal. Then we know, because, you kind of squeeze, right? So you kind of like, some people call this a sandwich theory. So you kind of squeeze that so that your gx has no, okay, so I should say here, this point here, this is the a. So that's what is the squeeze theory tell you. That means in this situation, because the f of x, so when they approach to a is here, h of x approach to a is here, so you have no choice here. So that means x approach to a to the gx has to be equal to the limit x approach to a to the f of x equal to the limit x approach to a to the h of x. I think, from the graph, it kind of makes sense, right? So that's why some people call it the squeeze theorem. Some people also say sandwiches, right? So it's a sandwich theorem because when you're getting closer and closer, now of course the three of them, they all have the same values here. Okay, so now let's take a look here. So they said, hey, I want to find, so we said the 3 to the power x, right? So we say, hey, I can squeeze it by the two functions here. One is x plus 1, and the other one is what? Another one is 2x plus 1 here, okay? So I want to find the, I want to find the x approach to 0, okay? So when the x approach to 0, so first let's take a look at x approach to 0 here. Okay, so let's take a look at limit x approach to 0 for this function x plus 1. What is this limit going to? When x approach to 0 is 1, right? Okay, so the same thing is limit x approach to 0 for the function 2x plus 1. What is the limit here? Is 1. See here, so 2 times 0 is 1. So because then these two bounded, so bounded, these functions, right? So this, 3x was bounded by these two functions. And the 3x was squeezed by these two functions. So I know what is the limit x approach to 0 to the 3x here. So this is because the x is greater than or equal to 0. So it's always approach from the right-hand side. So what is going to squeeze this one to? It's squeeze this one to 1, right? So it's kind of makes sense. You put a 0 in here, 3 to the 0 power is 1 here. Okay. All right, so now let's take a look at the next ones here. Okay, so the last problem for this lecture, they said, hey, is if f and x, they both exist, and I know the function fx less than gx less than hx for all the value near a. I think here, sorry, here, I think my graph is kind of backward here. All right, so now I should have put it here. All right, so here. Sorry here, so I give it a different, so this one's here, so f of x is higher, right? Go this way. Okay, so this one is the same here. I should say this. Okay. So this f of x is bigger. All right. Okay, so don't want to make a silly mistake. Okay, so the number 11, they tell you, they said, hey, we did a similar problem before. So this one is said, limit x approach to a, f of x and hx both exist. And f of x less than gx less than h of x for all the x near a. Then is the x limit x to the a exist? Well, okay, so is it always exist, or sometime exist, or never exist? Okay, so the answer by comparison series, we say this is just sometimes here. Okay, so what I mean, the sometime. Okay, so if this limit exists, if it exists, the function, if the limit exists, not necessary will be exist. So for example, if you have here, f of x is equal to the negative x squared minus 1. And then you have a gx here. Let's give a simple function, it's a sine x, right? Then the h of x, let's say this is x squared plus 1. Okay, so like I know the trig function is always between 1 and the negative 1 here, right? So I know for here, this is limit x approach to 0. Let's approach to 0. So the f of x is what? It's negative 1. So what is limit x approach to 0? Gx, right? Gx is what? Gx equal to 0. And then the limit x approach to 0, the h of x equal to what? X equal 1, right? So it's fine. So you do have some function exist here. Now let's take a look. Let's change here. That's the same f of x and okay, and h of x. All right, so the same ones here. So we said this is f of x equal to the negative x squared minus 1. Instead of gx, right? So I said gx, I changed that. I changed to sine 1 over x here. And then here the h of x is still remaining the same. So see here, this one's here, this is x approach to 0. This is still is negative 1. Well, better write it. So, okay, so this one's here. So this is f of x. This is still negative 1. This is limit x approach to 0. H of x is still 1. But how about limit x approach to 0 sine 1 over x? I know the sign doesn't matter what is the value. The sign is always between what? Negative 1 to the 1s, right? So this relation is still the same. So this relation still hold, right? So that means f of x less than gx less than h of x. So this relation still hold. But what happened to the limit x approach to 0? So when the limit x approach to 0 here, right? So I know that means the x is going to become this very close to 0. So the whole inside value going to be very big. But doesn't matter what is the value of the sine x is here. So this limit, you know, your function going to kind of like the oscillating here, right? Jumping around. So this limit is what? Not exist. Okay. So that's why. Then you will say why the squeeze theory doesn't work. Okay, the reason why the squeeze theory doesn't work here is when I approach to 0, right? One is approach to 1, negative 1, and other is approach to 1. It's not a squeeze. So like the f of x is going to like the here approach to negative 1. Then the h of x is going to approach to here, right? So to the 1s here. They're not squeezed, right? So it's not like they kind of go like this, right? So if they squeezed, then I know it will, because, but in here, one go here, one go here. So it's not squeezed. So even I have a function going in here, right? But because they don't squeeze that, so that's why, you know, we do can find some function, the limit is not exist, but even the function itself is still like the in between the two functions. The squeeze theory does not work here is because this true value, they don't really squeeze, you know, the function sine 1 over x there. Okay, and that's it. So this is our section 2.3, very interesting the sections, right? So the key things to remember is the squeeze theory, and also the limits law, and also three-way typical. Of course, they probably have different ways. You know, the three most commonly used methods to handle the fractions. If the fraction become to 0, how do you find the limits here? Okay, that's it. And it's nice to talk to you, and looking forward to talk about our next topics here. Okay, bye.